Hello, pre-calc. Today we're going to do day 4, limits involving infinity. This is really just like, I don't know, kind of an intro more so to day 5. If you didn't watch day 3 is very important. Make sure you watch day 3. Right now I'm going to run through this. I think it should be pretty quick. We'll see. Okay, so 1 and 2, same picture. I've got a parabola. I don't need to draw axes. I'm just going to draw the general shape. And this is the same idea of what you talked about in Algebra 2. So the limit as x approaches infinity, let's keep in mind, I'm going to kind of say something that's going to sound weird. I'm going to say there's 2 different infinities that we talk about. And I don't mean positive and negative. There's positive infinity here, negative infinity here, but then there's positive infinity here and negative infinity here. Okay, so our notation, x approaches infinity or x approaches negative infinity, this guy right here, that's talking about reading the x-axis. Okay, and my second one, it's off my page, x approaches negative infinity, is talking about reading right or left. When we answer a limit with infinity or negative infinity, we're talking about our y-axis. So we're saying, okay, the function goes up forever, the y's are increasing without bound, we're going to answer with infinity, or it's going down forever, negative infinity. Okay, so coming back to number 1. As x approaches positive infinity, the function goes up forever without bound to positive infinity. Number 2, same picture, this time limit as x approaches negative infinity. So I'm saying as we go left, this guy's going up to positive infinity. All right, numbers 3 and 4 are using the same picture. This time I am going to draw axes. This is exponential growth. How do I know it's growth instead of decay? Because that's a 2 instead of a number like 1/2. So that's how I know it's going up. Limit as x approaches infinity. These are called end behavior questions. Limit as x approaches infinity. As we go to the right, the function goes up. So this one is infinity. As we go left, however, that guy's not going past the x-axis. That is an asymptote at the x-axis. This function is getting closer and closer and closer to a y value of 0. If I were to plug in numbers like 2 to the -5, 2 to the -6, 2 to the -100, okay, your calculator might default to 0, but it never actually hits 0. That is getting closer and closer to 0. Okay, 5 and 6. I just realized it. I mean, I might be drawing these a little bit fast, but it's a video, so you can pause it. I'm taking the picture from above, and I'm raising it up 3. Even though this is not a parent function, like we can still apply these things. We've got 2 to the x, which is what we just drew above, and then a +3. That's going to raise it up 3. So the limit as x approaches infinity, well, as I go to the right, that guy's still going to infinity. As I go to the left, now it's not going to 0 anymore, it's going to 3 because it's been raised 3. Okay. Here we go. Oops. Okay, number 7. Let me erase that little mark I just made. 7 and 8. We're talking hyperbola. We saw this on day 2. Asymptote at 4. There's a negative, so I'm going to put the 2 pieces here and here because it would have been reflected. Limit as n approaches infinity. That thing's going to 0. If I have a horizontal asymptote, I'm going to recap this at the end, then my end behavior is wherever that horizontal asymptote is. That's going to be a huge part of tomorrow's lesson. Oh, 8 has a different picture. Okay, you may or may not know what this picture looks like for 8. They're both positive. The limit as x approaches infinity. Again, we have a horizontal asymptote at the x-axis. So that horizontal asymptote's at 0. That guy's going to 0. 9. This is a constant. Rule. The limit of a constant is the constant. Let's start number 9. You can jot that down. The limit of a constant is the constant. Because think about this. I'm asking as x approaches infinity. So yeah, as you go to the right, that's going to go to 5. As I go to the left, if I had said negative infinity, that's going to go to 5. If I had said any value in between, what's the limit as x approaches 1? 5. What's the limit as x approaches negative 10? 5. So the limit of a constant, the answer is that constant. It doesn't matter actually what I'm asking underneath it, even though that is the most important part of the limit. In the constant case, the answer is always the constant. Okay, why do we do polynomials before we do limits? Because if you look at our last, 10, 11, and 12, we're talking polynomials here. So if I know what this guy looks like, this is a negative sloping line. I don't need to graph that in my calculator. I know what it looks like. What's the limit as x approaches negative infinity? Well, as we go that way, this thing is going up to infinity. 11 and 12, I've got a positive x cubed. I don't need to know exactly what this looks like. I've got a positive x cubed. I know that when x approaches negative infinity, this guy's going to negative infinity. And I know that when x approaches positive infinity, this thing's going to infinity. Okay, 13's kind of a special case. The sine graph is oscillating. So when I try to talk about what's happening as x approaches infinity, it's not like going up forever, going down forever. It's going back and forth. This is a rare case where we would answer with the DNE because it's not approaching some number. Okay. All right, notice this is starred. When I ask you for the end behavior, anytime, this will happen, from now until the end of the year. I might give you a function, and then I'll say, what's the domain, what's the range, where is it increasing, where is it decreasing, what's the max, what's the min, and end behavior. And when you see end behavior, you are writing out limit as x approaches infinity of f of x, or g of x, whatever I call it. And you are writing out limit as x approaches negative infinity of f of x. And then you answer both of those questions. All right, I'm going to do a little recap of some things on a blank sheet of paper. Okay, here we go. Oops. Limit as x approaches 2. And let's say this is our function. What do? Well, we've got limit as x approaches a number. So we plug in. There's our answer to our limit. Okay. Now, let me erase this. Let's say we have limit as x approaches 2 of x squared minus 4 over x minus 2. We plug in. we get 0 over 0. That does not mean that our answer is 0. That does not mean that our answer is DNE. That does not mean that our answer is 1. These are all things people try to answer here sometimes. That is not the case. At this point, there's a factor that can be canceled out. And until we know what factor that is, and we actually cancel it out and see what happens, we don't know the answer. Okay, our answer could still end up being, any of the things I said before. So what we do, because when we get 0 over 0, we know there's a removable discontinuity. There's our removable discontinuity. Now I take 2, plug it into what's left, I get 4. Okay, we ended up having a limit. Now, what this doesn't show me is that graphically, that just means there's a hole in the graph. So the limit exists. Okay, let's try another one. Let's say we have limit as x approaches 2, but the top is like that. So this time when we plug in, we get 8 over 0. Okay, I don't have to go any further. I mean, I have to answer the question still, but I don't have to go any further in terms of like algebra or graphing or anything like that. If I get a number other than 0 over 0, then I know this is an essential discontinuity. If the function has an essential discontinuity there, the limit does not exist. Okay, that's a quick recap of lesson 3. Now, let me recap some of our end behavior stuff. Okay, if I have a horizontal asymptote at the x-axis, then my limit as x approaches infinity or x approaches negative infinity is going to be 0. Same is true for the horizontal asymptote being anywhere else. Like, well, the answer is not going to be 0, but the answer will be wherever that horizontal asymptote is. So if I want to take, our 1 over x graph, let's say, and shift it up 5. I got a horizontal asymptote at 5. Then my answer to the end behavior, the limit as x approaches infinity, limit as x approaches negative infinity, I'm just shortcutting it by not writing it out twice, is 5. The answer will be 5 to both of those. Okay, so those are graphs we know. Tomorrow you'll see some random graphs that just might look complicated, but if they have a horizontal asymptote at, let's call this 7, then the end behavior is 7. Limit as x approaches infinity is 7. Limit as x approaches negative infinity is 7. Okay, so we'll talk about tomorrow how you can figure out if a graph has a horizontal asymptote. And then if it does, yay, that's your answer to limit as x approaches infinity, limit as x approaches negative infinity. Okay, let's go back to polynomials. So now, here's stuff we should already know. We should know that if we have a polynomial that has an even degree, I'm just making this up with a 4, and it's positive, that its end behavior is like that. Okay, it might have a bunch of humps in the middle, especially as that degree gets bigger, but we know the end behavior is just the fact that it faces up. We talked about this a lot last packet. Okay, if it's a negative even degree, we know that the end behavior looks like that. It faces down. If it's an odd positive, I'm just going to make it something random, we know that it starts and ends increasing. This is all the stuff we should have from last packet. If it's odd and it's negative, we know that it should start and end decreasing. Why is this important? Because when I start asking you questions like limit as x approaches infinity, limit as x approaches negative infinity of these kind of functions, we're not going to go to our calculator. I could certainly give you something like, negative 5x to the 6th plus 2x to the 3rd minus 7x plus 2. I don't know what that looks like, but I could certainly answer both of these questions. Oops, call this f of x. If I see that the leading term is negative 5x to the 6th, I know I'm looking at something that's going to end like this. So in both of these cases, the answer would be negative infinity. If I was talking about something like, I'm going to change colors here. Let's say I'm talking about negative 2x to the 7th, okay? And I ask you the same two questions. Get rid of these answers. Now I go, okay, I don't need to know exactly what that looks like. I know that the general shape of it looks like that. It's odd and it's negative. The limit as x approaches infinity is negative infinity. The limit as x approaches negative infinity is positive infinity. So that's how we can do end behavior for a lot of things that we don't need to graph, just based on the general odd, even, positive, negative stuff we talked about last packet. That's all going to come into play tomorrow. Okay, try homework 4. Tomorrow's day 5. We will spend a lot of time recapping days 1 through 5 over the next, last part of the week. All right, bye everyone. Have a good one.